So next, we'll talk a little bit about thrust, about propeller, and how propeller generate the force that we need in the airship system. So propeller uses the flow of air particles to generate thrust for lifting or for movement in a certain direction. There are actually two major mechanisms involved in the process to generate the force that you need. First of all, the shape and the orientation of the cross section are designed in a way that it will drive the air particles downward through the cutting action. So the downward movement of the air particles will then generate an upward reaction force acting on the propeller according to the Newton's law of motion. The other mechanism for lifting is the streamlined cross-sectional shape is also designed such that air particles have to travel a longer distance and faster along the top surface to generate a pressure difference between the top and the bottom. This action will generate a force going from the high pressure zone to the low pressure zone according to the Bernoulli's theory. So the pressure difference will generate a lifting force. At the same time, the downward movement of the air particles will also push the propeller upward. By combining the two theories, we have the uplifting force in the propeller system. Looked at that, most propellers are designed to maximize the thrust through combination of the two theories, and this optimization can only be applied to one direction of rotation, which also means that the propeller that you have in hand is only designed for one direction of rotation, although you will probably still have a reverse thrust if you rotate the propeller in the opposite direction. But the magnitude of the force will be a lot smaller under the same driving power. So don't think that you can generate an opposite thrust by counter-rotating the propeller. Yes, you do have some kind of force generate, but it's a lot smaller, and you shouldn't design it for a counterclockwise rotational movement. So there are also propellers that comes in pair. And the advantage of having these pairs of propellers is that it will allow you to generate a forward thrust through different directions of rotation. One will generate the thrust in the clockwise direction, and the other one will generate the thrust in the counterclockwise direction. So the combination of the two will give you a net forward movement power without generating the reaction torque, because the reaction torque from the two propellers will cancel each other, as one is rotating in clockwise direction and the other one is rotating in the counterclockwise direction. So what you need to do is that when you look at the propeller, when you design your airship system, try to keep in mind that this propeller is rotating in a certain direction in order to generate the thrust. Don't rely on the same propeller to generate the opposite thrust if that thrust is very important in your design. Drag force. Drag is also called air resistance. It's the forces that are in opposition to the relative motion of an object through the air. There are different types of drag. The first one is pressure drag. Pressure drag is the inertia of the air particles. Bear in mind that throughout the journey of your airship have to move the air particles away in order to take up the space that the air particles is originally taking up. So the ability for your airship to move the particle away is governed the magnitude of the pressure drag. So in the calculation of pressure drag, we have to look at the shape of the object. If the object is having a very streamlined body shape, then the drag coefficient is a lot smaller. In case of the airship, you are probably using sphere balloons, and the drag coefficient is relatively large, which suggests that in the design of the airship, you have to take this pressure drag into consideration. Apart from pressure drag, we also have skin friction drag, which is also a significant factor when the movement speed is relatively low. So the friction drag depends on the material forming the surface of your airship. How smooth it is. If it is rough, then the skin friction will be a lot larger. There is also another kind of drag that is caused by the aerodynamics of the system. And the drag will generate when there are vortices generated. But in the case of the airship, we don't really need to worry too much about the aerodynamic drag because the movement speed is relatively low. It's too low to generate significant vortex throughout the journey. So here is a picture that will give you a basic understanding about what kind of drag that you are going to consider in the airship design. In the situation where the speed is relatively low, we only need to consider the friction drag and the pressure drag. And the percentage of the pressure drag depends on the shape of the system. If you are having a very bulky circular shape airship, then the pressure drag will be very large. It can be as large as 90%. So you always want, if you want to reduce that pressure drag, you always want to try to think about the alignment of the helium balloon such that you can reduce the drag in a certain direction.